All right, as promised, here are a couple of examples of graphing logs to finish up our lesson from today. So I'm going to choose to do number 3 and number 5. So as we mentioned in class, usually the most efficient way to graph logs is by choosing numbers that are compatible with the log base. So you have to kind of take a look at the log base you have and work with it that way. So in this case, I have log base 2, right, of x minus 3. So I want to choose numbers that when I evaluate the argument, this x minus 3, the numbers are going to be, the result is going to be some power of 2, because it's really easy to calculate the log of a power of 2. All right, so in my table of values, x and p of x, I certainly, if I choose 0, well, then I'm going to get a negative number, so that's a problem. So I actually hopefully recognize that I have to choose numbers that are bigger than 3, right? Because anything less than 3 is going to give me a negative argument, which is not possible. So the first number I can choose is 4 here. If x equals 4, then I have log base 2 of 1, right? So I can write that out here, right? So that becomes negative 2. Log base 2 of 4 minus 3 is 1. Well, the log base 2 of 1 is 0. So that is 0, that cancels. 0 times negative 2 is 0. So 4, 0 is a point on this graph. And I can go ahead and plot that if I want. Right? So the next number that I might choose is the next power of 2, right, is 2 itself. So if I choose x to be 5, 5 minus 3 is 2. So now I have negative 2 log base 2 of 2. Log base 2 of 2 is 1 times negative 2 is negative 2. So the point 5, negative 2 is on my graph. And then finally, the next power of 2 I might choose is the number 4. So what minus 3 is going to give me 4? Well, that's 7. So if I do negative 2 log base 2 of 4, that's going to give me negative 4. So 7, negative 4 is a point on my graph. All right, and I'm not super familiar with log graphs yet, so I'm not totally sure what shape this is going to take. I have an idea it's going to be some kind of a curve. So I'm going to think about what else I know, and I know that the domain of a log is limited by its vertical asymptote, and hopefully we remember that the vertical asymptote is appearing inside my argument here. So my vertical asymptote in this case is going to be at 3. And this gives me a pretty good idea that this graph is going to creep up pretty close to that vertical asymptote, and then it's going to go down in this direction, and it's going to keep going. There is no horizontal asymptote. I'm not totally sure what those points are beyond 7, but I can kind of give it a good sketch. All right, so then I can go and do this analysis. Well, we already talked about the asymptote being at x equals 3, and that again is coming from the limits of that argument, right? My argument of a log can never be negative, so basically whatever value makes the argument 0 is going to be my asymptote. My domain in this case is everything from 3 to infinity, right? Because we're going to start at that asymptote, go to infinity, not including either of those. The range of any logarithmic graph is all real numbers. And then my x and y intercepts, well, I can pretty clearly tell from my graph that I don't have a y-intercept. And again, my y-intercept happens when x equals 0. So if I look up here, if I plug in 0 for x, well, then I'm going to get that negative 3 in there. Log base 2 of negative 3 doesn't exist. So that's just another way to verify that indeed I don't have a y-intercept. My x-intercept is, we can see on our graph, is 4, 0. But again, if it wasn't on the graph, I can simply plug in 0 for y to find my x-intercept, x minus 3, and then I can actually do all this math here, right? 0, this negative 2 is going to cancel the 0, so then I'm going to get 2 to the 0 is equal to x minus 3, so that is 1 is equal to x minus 3, and x is equal to 4, so my x-intercept is indeed 4. All right, so let's look at number 5. Number 5, negative 3 plus log base 2 of x plus 2. So we're still working with the same log base. We want to think about those compatible numbers. Right? In this case, if I choose x equal to -1, right, that's going to give me log base 2 of 1, and we know log base anything of 1 is always going to be 0, so -3 plus 0 is -3. I can choose x equal to 0, because that's going to give me log base 2 of 2, and 2 is a power of 2, so that's going to be helpful to me. Log base 2 of 2 is 1, plus -3 is -2. And then another compatible number in this case is going to be x equal to 2, because that's going to give me log base 2 of 4. All right, so log base 2 of 4 is 2, and add -3 to that, we'll get -1. And if I wanted an additional point, I can choose, in this case, 6, right? So 6 will give me log base 2 of 8, which is 3, plus -3 is 0. So I have actually 4 points here that I can plot, right? -1, -3, 0, -2, 2, -1, and 6, 0. And this gives me a pretty good idea of what this graph is going to look like. And actually, my x and y intercepts are taken care of for me in this graph very nicely. So we have an x-intercept of 6, 0, and a y-intercept of 0, -2, and those just fell out for us very nicely in our table. If they didn't, we could always go back to the function and plug in 0 for x to get the y-intercept, and plug in 0 for y to get the x-intercept. The asymptote, again, I can see in my function. It's whatever's happening inside my function. It's that horizontal shift, right? And I could kind of see that it's approaching it from the points on my graph as well. So my asymptote is a vertical asymptote at x equals -2. I could draw that. And I can draw my graph, give it a little sketch here. And the domain is limited by the horizontal asymptote. So we've got -2 to infinity, and the range of any logarithmic function, again, is all real numbers. So that's it. So again, try the rest of these for homework tonight, and then in class tomorrow we'll kind of regroup and see how everyone's doing.